So, I don't necessarily like the way I'm doing this with the F applied. We're just going to say if F net equals some constant. Okay? Then mv prime plus gamma v squared equals that constant. So v prime equals the constant minus gamma v squared over m. And this is an easily separable equation. So you have dv over and there are many ways it could have been written, so I'm kind of debating, but so it separates out, could separate out like this. What I really want to do is I want to factor the c out here. Okay? So I want to multiply both sides by c. And that gives me dv over 1 minus gamma over c v squared equals c over v dt. Then, integrating the right-hand side, of course, we're going to get a c over v times t plus an integration constant, so I probably shouldn't have used c here. Okay? So I'm going to call that d, and I'm going to change the c to a d because it's easy to do that. Okay? Okay, now, how do we integrate this? Well, we're going to use partial fractions because this denominator factors, right? So we have dv over 1 minus the square root of gamma over c times v times 1 plus square root of gamma over c times v. And this is going to be and I'm not sure how my m became a v, but it's the kind of thing that haunts my life if I'm trying to actually get correct solutions. Okay? So, we have that times t plus an integration constant, and I'll call that one c. Right?
Right.
Okay? Hey, Jane.
Lone wolf again, huh?
You can photobomb. Okay, so we got to go to partial fractions, right? So, 1 over 1 minus the square root of gamma over c v times 1 plus square root of gamma over c times v should equal some constant a over 1 minus square root of gamma over c v plus b over 1 plus square root of gamma over c times v. Okay?
Right.
Which means that 1 is going to end up equaling, now put these over common denominator, right? So a is going to be multiplied by 1 plus this, b is going to be multiplied by 1 plus this, then the denominators will be equal, and I'm not going to go through those details. We get then a plus b, because we'll get an a by multiplying this b here, right? And then plus square root of gamma over c times v times a minus b. Okay? Well, from this then, we see that A plus B has to equal 1. A minus B has to equal 0, and the gamma over CV doesn't even play into it. Okay? Just that, you know, this is the coefficient of V, and the only way that coefficient is going to be 0, as it has to be since there's no V here, is for A minus B to equal 0. And it's very clear then that A and B are both going to be 1/2. You go through the formal solution of this, but we can do that one actually by inspection. You know how to solve two simultaneous equations and two unknowns, so there's nothing to be learned there. Okay, so now, so we have, now this equation becomes, I wrote down the integral over here and I didn't put an integral sign in front of this, okay? Which is kind of ignorant. Okay, okay, so we have now the integral of dv and we're going to have a 1/2, right, over 1 minus square root of gamma over CV. Okay? And it's going to be, well, that's going to be plus 1/2. So we'll just factor out the 1/2. And we're going to have gamma over C times V, okay? And that's going to be D over M T plus C. And then the integrals are simple, okay? We're going to let U in both cases be square root of gamma over C times V. Okay, so then we're going to have a 1 minus U and a 1 plus U. It's going to give us a couple of natural logs, right? Right. And so we're going to then end up with 1/2. Now, because of the U substitution, okay, if I write that out just for the details and make sure I do it right, if U equals the square root of gamma over C V, actually in this case I'm going to let U equal negative this, and here I'm going to let U equal square root of gamma over C V, so I don't have to worry about the plus and minus signs. Okay? I mean, since they're taken care of. Okay? Then du is going to be a negative square root of gamma over C dv, right? Which means that dv is going to be a negative square root of C over gamma times V, right? So, skipping a lot of stuff, and hopefully skipping it correctly, we're going to have a C over gamma, right? And then it's going to be times the natural log of the absolute value of 1 minus gamma over C square root times V, except it's going to be a negative natural log. And of course you can verify this now by taking the derivative of this and finding out that you do get this, assuming I'm right, and I think I am. You know how that is, okay? And then it's going to be plus a natural log of the absolute value of 1 plus square root of gamma over C times V. And that's going to equal D over MT plus C, right? Right. So that now, well, we can combine these natural logs, and we've got this, okay? So we end up with the natural log of the absolute value of 1 plus square root of C over V over gamma gamma over C now, times B, over 1 minus square root of gamma over C times B. And the square root doesn't extend to the B. Okay? And this is going to equal, well, I'm going to just multiply by the reciprocal of my constant. Okay? And it's going to equal 2. And it's going to be, okay, we're going to have a square root of gamma over M. Okay. Now my gamma over C can't be because this is not the integration constant. And I had gamma over C because...
Well, you changed the gamma over C.
Yeah, I changed my C's to D's.
Yeah.
Okay, but I didn't change these C's to D's. So these gamma over C's are all gamma over D's.
I knew what you were talking about.
Of course, D wasn't good because of the dV, but we can deal with that. Okay, so that's going to be a D, and all these are going to be D's. That's going to be a D. That's going to be a D. That's going to be a D. So's that, so's that, so's that. Okay? And I'm probably still missing a couple, but you know what I'm talking
I know
about.
what you're talking about.
Okay? So what's going to happen then is you're going to have a square root of D. Yeah, because you're going to have a square root of D in the denominator. It's going to divide this, giving you a square root of D. So it's going to be square root of gamma D over M. Okay. And then that's times T plus your integration constant C. Which means then that 1 plus the square root of gamma over C times V over 1 minus the square root of gamma over C times V equals E. Well, and you know that E raised to this plus this is E raised to this times E raised to this, and E to the C is a positive constant that we'll call A. Then it's E to the 2 square root of gamma D over M times T. And at this point, you should do a dimensional analysis and make sure all that makes sense. Okay? But then you got to solve for V. So you're going to get, well, we're pretty much out of time, but solve for B, check the dimensions and return. Okay? And that gets somewhat algebraically complicated, so we can pick up on this next time.
All right.
If you choose to want to do that. Okay?